So let's say you're given a curve y. Are you seeing the screen now?
Yes, sir.
Yes, sir.
So let's say you're given a curve y is equal to x squared minus 5x plus 6. And you're asked to find, let me see, the equation, or just the slope of the tangent. Let's start with the slope of the tangent. I won't go straight to equation. Find the slope of the tangent at x equals 4. Right? And then you're asked to find the equation of the tangent as well. So you can just make a note of this. You're given the curve or the function y is equal to x squared minus 5x plus 6, and you're asked two things. The first is the slope, and the second is the equation of the tangent. Just let me know when I can move on, please. So, we all know what a tangent is. Can someone please define the term tangent, please? What's a tangent? Wait, no one's talking with me? What's wrong, man? Both, I'll put them together. So a tangent, very good. It's a straight line that touches the curve. A curve actually, right? It doesn't necessarily have to be a circle. Any curve at one and only one point. So a tangent can only touch at one point. If it touches at more than one point, then it's not a tangent. That's basically the definition of a tangent, right? It touches the curve at a single point. Is that clear to everyone?
Yes, sir.
Great. So, when this is one thing in calculus that you're usually asked to find the slope of the tangent. Now, the slope, what's another word for slope?
So gradient.
Very good. So basically what we're asked to find is the gradient, and gradient is the rise over run. Am I correct?
Yes, sir.
Okay. So whenever you're asked to find the slope of a tangent, what they're actually asking you to find is the gradient. We use the letter M for gradient, right? So let's look at this particular question here, and I'm going to show you how we'll go about answering a question like this. If we were in a physical class, what I would have allowed you to do is to draw the curve y is equal to x squared minus 5x. After you draw the curve, I would have asked you to identify the point when x is 4. And I would have asked you to take a ruler and see if you can find that tangent line. Unfortunately, we can't do that, but I have an alternative. So I want you to actually see what it's all about. So I'm going to use GeoGebra, and I'm encouraging you to use GeoGebra as well. So it's x squared minus 5x. Just let me know if you're seeing the screen, please. This thing be as funny sometimes.
Yes, sir.
Plus 6. Alright, so can everyone see the curve there?
Yes, sir.
Yes, sir.
It's in green, right? So what are the roots of this curve? I'm going back in algebra. What are the roots? Right. The roots of a curve are the x values where the curve cuts the x-axis, right? So your roots would be 2 and 3. Those are the roots. Just by the way. Now we are asked to find the tangent of this curve at a particular point, right? Which point we are asked to find the tangent? The slope of the tangent. At what point? Let me see if you remember. No one can remember the original question? We said we want the slope of the tangent at x equals 4. So let's see what's happening at x equals 4. This is x equals 4. So I go at x equals 4 and I go straight up to the curve. So at this point here, I want to know what the tangent will look like. Is everyone following so far?
Yes, sir.
Yes, sir.
Anyone else? Great. So what we want now, we want to draw a tangent that touches that curve just at that point there. So the answer that we are looking for is the gradient of this straight line that will just barely touch the curve at A. That's when x is equal to 4. Alright, so I'm going to show you what our solution is. So I write tan, and I want the tangent, the x value. So I want a tangent when x is equal to what?
4.
4, sir.
4. Very good. And our function is f. So I'll just plug in f. So do you see the tangent line now? Yes, no?
Yes, sir.
Yes, sir.
Oh boy, what have I done?
Yeah.
I tried to zoom in. Oh. Aha. Now I need to zoom out a bit. Look, so you can clearly see the tangent line. To find the slope of the tangent, it's already given here. We have the equation. The equation of the tangent is given 2. What's the equation of the tangent? It's given right here.
3x, y equals 3x minus 10.
Very good. So that's the equation. So basically we have our answer there. We have the slope because the slope is the m value. Y is equal to mx plus c. And the equation is y is equal to 3x minus 10. So what's our gradient value?
3, sir.
What?
3.
Yeah, that's our gradient value. Very good. It's m or m value. So it means the slope of the tangent at x equals 4 is 3. That's the slope of the tangent. Now the equation of the tangent is the entire thing. The equation is this line here. Y is equal to 3x minus 10. So what I did there is to give you a visual representation of what your answer is. Now I'm going to show you how we'll use calculus to actually work this out. You're giving a question, you don't have to draw the graph, but I just wanted you to see that we can use a method simply by drawing to get the answer that we are looking for. So let's see how we'll answer this question using calculus. Where am I? So let me clean up here. So anytime you're asked to find the gradient function, we have y is equal to x squared minus 5x plus 6. And we are asked to find the tangent at a point. tangent, we ask to find the gradient of the tangent actually, right? The gradient of the tangent. Let me use the correct terms. Whenever we differentiate a term, when we find dy dx, the answer that we get is called the gradient function. The gradient function. So when we differentiate, that answer that we get, the first derivative, the answer we get is called the gradient function. So let's differentiate this function. Remember, multiply by the power, subtract 1 from the power. What's our answer when we differentiate?
Sir, 2x minus 5.
2x minus 5. Right? Everyone agrees with this? Multiply by the power, subtract 1 from the power. Everyone agrees with this? Yes, no?
Yes, sir.
Yes, sir.
When we did differentiation before, so it's basically x squared will become 2x and minus 5x will just be minus 5. So this is called the gradient function. So if you want the gradient, at any point, you just substitute the x value. So we want the gradient when x is equal to 4. So when x is equal to 4, we want the gradient of the tangent. When x is equal to 4, we just substitute. M, the gradient of the tangent, is equal to 2. We substitute 4, or x value, minus 5. And when we work that out, what do we get?
3, sir.
Right? 2 4 is 8. 5 from 8 is 3. So you see we got the gradient that we found there. So we see that the gradient of the tangent at x equals 4 is 3. Right? So you can just make a note of that. So you can take the work here before I go on to the finding the equation of the tangent.